Have you ever found yourself puzzled by assembly language instructions? If so, you're not alone. Today, we're diving into the intriguing world of Intel instructions, specifically the difference between MOV RM8, R8, and MOV R8, RM8. I totally get it. Assembly language can be confusing, especially when you're trying to understand why one instruction is chosen over another. You're not the only one who has faced this challenge. Many programmers have been there too. Let's look at the specific question at hand. One user asked, why does NASM choose MOV RM8, R8 over MOV R8, RM8 when I write MOV ALBL? This is a great question and one that many might wonder about. To understand this, we need to look at the instruction formats. The first instruction, RM8, R8, moves data from a register or memory to a register. The second, MOV R8, RM8, does the opposite. NASM chooses the first based on the operands you provide. Stay with me. By the end of this video, you'll not only understand the difference, but also gain insights into how NASM makes these decisions. To understand why NASM chose the first instruction, we need to look at the operands involved in the MOV instruction. The user is moving data from one register to another, specifically from the BL register to the AL register. In this case, the user is using the MOV instruction with the operands AL and BL. The AL register is an 8-bit register, and BL is also an 8-bit register. This means that the instruction fits the first format, MOV RM8, R8. The second instruction format, MAR8, RM8, would imply moving data from a register to memory or another register. However, in this scenario, the user is not moving data from AL to BL, but rather from BL to AL. Additionally, NASM optimizes the instruction selection based on the direction of data flow. Since the user is moving data into AL from BL, it selects the MOV RM8, R8 format as the most efficient option. In summary, NASM chose the first instruction because it matches the data flow direction from BL to AL. The second instruction format is not applicable in this context. Fun fact, the first assembly languages were developed in the 1940s. Can you imagine programming back then? It was a whole different ballgame. Now, let's look at the answers provided by other users. This user explains that the two MOV instructions exist because a mod or M byte can only encode one memory operand. To accommodate both MOV R8, M8, and MOV M8, R8, two encodings are necessary. NASM randomly chooses one encoding when both operands are registers, and there's no specific reason for its choice. Interestingly, some assemblers have been known to watermark binaries by selecting instruction encodings in a particular way to track unauthorized use. That's all on that answer. Let's take a look at another one. According to another user, the choice of MOV RM8, R8 over MOV R8, RM8 in NASM seems to be a matter of preference. They noted that the encoding is based on a lookup table, which means it could have been designed differently. The user also mentioned that using the second opcode could simplify the code, especially for asymmetric instructions like add PS. The user explored the octal encoding of x86 instructions, explaining that the opcode structure consists of 3 parts: group, operation, and flags. They highlighted how the mod RM byte helps select addressing modes and registers, allowing flexibility in defining source and destination registers. Here's a pro tip. Always check the operand sizes and types when writing assembly code. This can save you a lot of confusion and debugging time. And there you have it. You now understand the difference between MOV RM8, R8, and MOV R8, RM8. If you found this video helpful, don't forget to subscribe for more insights into assembly language and programming tips.